This is a long chapter, but it's stuff that we've actually covered to a large extent. So cross-site scripting is the most common vulnerability in the world. 80% of websites have it. Most people don't care and they won't bother fixing it. There are whole blogs full of cross-site scripting vulnerabilities just posted to blogs because nobody cares. It's technically illegal to find it and illegal to tell people about it, just like everything else under the CFAA, because you are not authorized to know about the security of somebody else's server. Unless they hired you to do a security audit or something, you are not supposed to be inspecting their security, but it is so easy to find, people find it all the time. So the main thing, however, is it lets you attack other users. It does not let you attack the website itself, so most websites don't regard it as a high priority because you typically can't steal data from them. It just lets the users abuse each other, and they like to pretend that that's not really their problem. So there's three types: reflected, stored, and document object model based. Reflected is the most common. If you have a page where you type in something and then the next page repeats it back to you, like you search for frogs, the next one says results for frogs. This is all over the place. If it doesn't scrub it, then you can put script tags in what you put in, and when you come to the next page, it'll execute script in your browser. And that's reflected XSS, and at first glance it seems completely useless because you can run code in your own browser. Well, you could have done that anyway. And so that's the typical thing here. You can put in a script, and when it comes back, it'll pop up. But the reason it's a problem is because you can log in here, this process, then the attacker feeds, so the original, the target logs into some service. Then they attacks you, find a reflected cross-site scripting that attacks you, and then you craft a URL out of it. So let me get to my demonstrations here. There's logic flaws, and if I go to the root of this, there's some XSS pages too. Here's one of them. I may need some of the others later. All right, so that's pretty rude. Let's go to my the old one here for the moment. There you. All right. So this is the first one I wrote years ago. So we put in your name and log in here, and this repeats Sam. Now there's actually a cross-site scripting vulnerability there. By the way, when I tried this yesterday, it was going to a porn site, so it reminds me to erase the comments before I use it, because you can totally do that. So anyway, so now if I put in one of these, the alert, this is typically what you do to demonstrate the vulnerability, is put in a script tag. So when I put that on my message board, now when I view the message board, it pops up a box. It's running script. So I'm running script on my own page. The reason why this is a problem is I can often create a URL that will have that effect. Now in this case, it moved it in with something else, with a post or something. What I'd have to do is get the post that put the comment there. Anyway, and if this was this is stored XSS, not reflected SSS. But anyway, the point is, I wonder if I can do it with the other. I think I can do it with the other one. Let me go back to before I load. This one here is reflected, I think. I didn't think of it that way, but I think it is. So if I do this, I put in a name with a script tag in it, and then log in, then I get something popping up. And that is a request that I could have stored. That's a post request that I get somebody to make. Anyway, it's easier to understand when you have a GET request and it's all just here in the URL, but there is a request, and if I can trick someone into making that request, they will then run script in their browser. So let me go back to this here. So that's the point. You weaponize it by making a crafted request where they have a domain name like facebook.com, and then in the URL is all this code, which is going to execute when they click the link. So then you trick them into clicking that link somehow. That's the social engineering part. And when they do, then this is the attacker. When they click the link, they will then fetch the cookie and send it to me, and I've got it. That's the point. And this is very powerful. It works very well. So you log in normally, you get a cookie like this, some session ID with a long number. Then somehow I trick the user into clicking a stupid link like this, which has got JavaScript in the link. So typically what you do is go to one of those URL shorteners so it's not as obvious how evil this link is. But most users never look at the links anyway, and if they're using mobile devices, they can't even see the links. So it's really not that hard to get someone to click on something even when it's this obviously evil. And now that they clicked on that link, it's now going to take their cookie. You can see it doing document cookie script. It's going to send their cookie off to some server under my control. And I'll harvest it on there with a PHP script or by just looking in the server logs. And now I have your session cookie. So I can now enter your session from a remote location and be in your session, and typically forever. And even when you log off, even when you change your password, the old session cookie typically works forever. That's the game. So if you have a persistent cookie, which is the way they almost all are now because of mobile devices, then you have Remember Me working, which is typically on by default now for mobile devices. You log in and it just remembers you forever. So all I have to do is get you to click on a link, and then I get your cookie, and now I own you forever. All right, now the same origin policy is the primary security boundary in browsers, and this is why cross-site scripting is so powerful, because remember, evil.com cannot read target.com cookies. It will only let cookies go to the same URL. That's why I can't just send some kind of request from my site to get your cookies. I have to make it appear to come from target.com. And that's what cross-site scripting is for. I get to add code to a URL that started with the domain I'm interested in, like Facebook. And now, so your browser thinks it is sending that cookie to Facebook because the URL started with Facebook and then had code later. It didn't know that it's actually going somewhere else. Seems like you could program browsers to be smarter about that, but anyway, it's not happening anytime soon. So stored XSS is like that message board where it's not in the URL, it's stored on some kind of page. And now I just have to get someone to view that page. The nice thing about this is I can put up one attack and then millions of people might view my page and I don't have to do anything more, and all these credentials just come rolling in. So that's the one that you've got here. The attacker submits a question to like a forum containing malicious JavaScript, and now everybody that views the question will now send their cookie to me. So I'll just have a whole library of stolen cookies. And that's that type. The more complicated one I've read about and never understood. Yeah, go ahead.
I was just going to say that there is a way to solve this in the future. It seems like, I don't know what stage it is in right now, but I know that the way that they want to solve it is that you will have a policy on your page where only whitelisted elements can have JavaScript.
Yes.
And then as a developer, you will only whitelist whatever elements are allowed to have JavaScript tags.
And that'll be sort of like an HSTS kind of tag, right?
Yeah, so
Yeah.
if someone then gets the JavaScript in the right place, if it's not whitelisted, which in most cases it will not be, because of this whitelisting policy, then you will not be able to get your JavaScript to run, even if you get it to be on the page.
Well, that's good. And the other thing I think in the project you saw before is, in fact, most modern browsers will block a lot of this. They actually notice suspicious links. If you try doing cross-site scripting attacks with most browsers, they won't run. Not anymore. There's a thing called XSS Inspector that blocks them. So in DOM-based XSS is a little bit more obscure. You have a URL. This happens if the something in the URL is used to create something on the page. And this seems to be true in modern things like Google Maps and stuff. So your JavaScript can read the current URL, and it can and a script developers do write scripts where they extract something from the URL and put it on the page. And when I look at like the Ajax that does Google Maps, it looks like this. The actual queries have like latitude and longitude in them in the URL, which are then pulled down and used to make the map. So it is a way to write things, but that means, so here's an example of a dynamically generated error message. And I think I made a demonstration of this. Yeah, let's try this DOM-based SSS. It's probably a little more clear if you see it live. You have to figure out where the heck I put it. Control Z, all right. It's on my, or I'm losing my mind here. There, it's on XSS 4, all right? I should have an XSS page of junk here. Let's try that. XSS.htm or something. Oh, good. All right. Good. So here's reflected SSS. All right. So you have a message. And now you submit, and it prints out this response. This is the simplest one. All right. Developer is drunk. So now if you put in this, of course, and submit, then it doesn't work, and you wonder why it doesn't work. And the reason it doesn't work is because if you go to developer inspect, perhaps, let's see, it's developer tools. Where the heck are they? Chrome developer tools or something?
If I click on the page.
I tried that. Developer tools are here somewhere. I don't see them.
Inspect.
Inspect?
The whole thing.
Okay, good. And if I go to the console there, the XSS auditor refused to execute a script. So the browser does include some kind of auditor that notices suspicious scripts, and it blocked this one. And that's true of most of my browsers, but if you want the sleaziest browser, it's always Firefox. It used to be Internet Explorer, these days it's not. So Firefox is the only one that will fall for this stuff. So let's go to attack. Okay, and then xss.htm. Okay, so there we are. So now, if I put this in Firefox, it will now pop up. So it doesn't have that XSS auditor thing, and most of the others do. So, all right, then I've got more reflected demos here. I think this is the one we've already seen. No, okay, here's some more. This one I should be able to click, yeah. So this is a on-click element that, here's the on-click element that pumps up the cookie. Here's one that opens a pop-up window with something in it from another server. So that's, and here's one that sends your cookie to a remote log. And this was one of the projects. So now these values are appearing on my server and being harvested there. One thing I kind of wondered would happen is that bad guys would actually start using my server to steal real stuff, which totally could happen, but it hasn't happened yet. Anyway, and that's why I put this button here to clear the log file in case there's actually something bad in there. Anyway, then there's stored XSS here, and that's the one you've already seen. All right, where you store something and everyone who views it will see the attack. And then there's DOM-based XSS. So here's the game. This is a page that uses something from the URL to make the page. So up here it has message equals hi. So in the page is some code, and that is used to put the message here. And here's the script that does that. You use JavaScript to go to URL, you get the URL, then you look for the message equal, then you take whatever's after that, and you call that the message, and you put it here. This is what some developers actually do this. It sounded incredibly contrived to me, and I first heard of this like 5 years ago, but this apparently is the way a lot of real pages are made these days. You can actually harvest something from here and puts it there. And of course, if it's going to do that, then you can just put JavaScript up there, and it will then be on the page. So the message is script alert hi, and now it's popping up here. So this page takes the message up there and puts it on the page, hi. And I can put code up there for the message, script alert hi. And it will put code there and run it. So now I can make a malicious script here that steals your cookie and sends it to my server and email it to people, and it will work. If so any site, and this is what tends to happen to people like Facebook and stuff, they have all these pages, one of their pages uses this technique of coding and has DOM-based XSS. As long as any page in the facebook.com domain has that, I can make a URL that the browser will interpret as part of Facebook, and it will cheerfully send Facebook cookies to it. So this is why you can have a secure site and secure policies, but if there is one clown anywhere in your company that makes one stupid page, it's all shot. Just like, you know, if somebody leaves the door open somewhere, it doesn't matter how many other people are locking the doors. So you have to have like continuous scanning of your website and reviews and all sorts of boring things like that to try to pick up this stuff before it happens. It's every security policy has the same issue. I mean, you have, like what happened to the NSA, right? They've got all these people, they're loyal, and then you got one Snowden someplace that's just going to hand it over. And how can you make sure you don't have one clown somewhere that is doing the ultimate thing you don't want done? It's very hard. Anyway, and so it's all the same story. And he ends up hijacking your session because he stole your cookie, and he stole your cookie because he was able to make a URL that your browser perceived as a legitimate URL from that domain, but in fact sent the cookie somewhere else. Right. Here's some examples of real-world attacks. Remember this one, Apache? In 2010, the Apache project had a cross-site scripting in their issue tracker, where you could make complaints and developers could track the issue. So an attacker injected code and obscured it, and then an administrator clicked the link. So he got an administrator cookie. So after that, he changed the upload folder for the project, the Apache project, and he put a Trojan login form there. So when people tried to upload code, it would pop up a box asking them to log in. And so he got a whole series of administrators' usernames and passwords, people who were expecting to upload code to the project. So he found passwords that were used on other systems in the infrastructure, and he fully compromised those systems and took over the whole mess, not just the Apache project and their code, but all their servers and everything. It was pretty gruesome. And it all started with cross-site scripting. Then there's MySpace. This is the most famous one that made the whole world aware of it. This guy named Sammy. There was a filter to block cross-site scripting, but the filter wasn't very good, so like the one that forgot to backslash the backslash, there was some characters blocked, that he found some that weren't, and he was able to inject cross-site scripting, so he put JavaScript in his user profile, so everybody that saw his username would immediately add him as a friend, copy script to their profile, and so in like a couple hours he had 1 million friends. He was the most popular guy on MySpace within a couple hours. He was everybody's friend, because it geometrically exploded. And Then, this is the one I mentioned before, Strong Webmail was one of the first two-factor authentication solutions. He offered a $10,000 prize to anybody that would hack into his email. So they found a cross-site scripting vulnerability, sent him a PDF, which when opened, would send the cookie from his machine to them, and they got in his email that way. Because, of course, on your own trusted machine, it doesn't bother with the other factor of the two-factor. And he didn't have any anti-CSRF tokens in his cookie, which he should have, like an IP address, so it couldn't be used on another machine. He didn't do that either. So realistically, it's exactly what he said. He was saying, I did everything right, so you can't hack it, and he really didn't do everything right. He had this two-factor thing, which sounds great, but two-factor alone is not enough to save you if you make other mistakes. Then there's Twitter in 2009. I remember a couple of these cross-site scripting worms. There were these things popping all over the place. Mikey made this attack. It was behind the attack. He made the worm, and he made another one. Again, it would pop up on everybody's machine and do something crazy. Someone would freeze your machine. Remember, one of them would crash your browser. Remember, this one here got my attention because it only affected people who used the twitter.com page. If you used third-party apps like TweetDeck, it didn't happen. But if you're using the Twitter page, it would forcibly retweet to everybody else. So everybody was getting hit by this thing. And it was just, your timeline was filling up with all these retweets and retweets of something. So you can do a lot of things. You can make a virtual defacement. Like, remember that back here on this one, I just reflected thing. It was this one I was looking at. Let me see if I can find it. This one here. Yeah, this DOM-based one. I can put a script there, and it appears on the page. So I could do this with a script. I could do this as well. This one's going to pop up a box if I do it in the vulnerable browser, which is Firefox. Here, Firefox. Okay, there we are. And so this is going to do the alert. I could just as well put an image tag here, and then an image would appear from another server. I could put an iframe here, which is the most popular thing bad guys do. And then there's a frame there with code from another server. And you typically shrink the iframe to size 0 so it's invisible, but it includes malware. So now they're at my site, and they're getting malware from another site. And if the search engines get a wind of that URL, because I'm posting it on forums and stuff, then they will flag my site as hosting malware. Because people do go to my site and end up with malware, and it's not really their problem to know that it didn't exactly come from my site. The fact is, by leaving a bouncing spot on my site, bad guys can bounce malware off my server and hit people. And so even if it's not living on my server, it's coming from my server and hurting people, and I get blamed for it. All right. That was Twitter. Yeah?
One more thing is that with XSS, you basically give the attacker the option to execute code on your machine.
Yes.
And there are browser exploits that will install a backdoor on your machine. All you need is to be able to run JavaScript. This is especially common if you are running an outdated version of your browser. But even if you have the most up-to-date version, if you're valuable enough, then you can just deploy a zero-day exploit that uses JavaScript to decode the machine. And once you do that, you can basically have a permanent backdoor. And all that just from having someone run JavaScript that was done through XSS. So it can basically lead to a total compromise of the machine. And with XSS, you can see who it is. So if you just want to target, say, I don't know, the CEO of a company, then you will only give it to this one person, and everyone else will not be able to get this exploit. So you can stay under the radar. Yeah,
they're right. Those are good points. That's why I think this this XSS blocker that's in most browsers is a pretty good idea. And I don't know quite how it works, but I know if you make simple access, I think it just detects obviously stupid stuff like script tags in the URL and blocks them. Anyway, so you can add something else you want up there. Oh yeah, this is one that's cute. Our business was acquired. Please go to evil.com. Now they'll see this. This was in the book. They had one like this. So our business, we sold our business. So we go here. That's people are likely to click on that link, and you can do it to a business that's still up because they have this. By the way, I didn't get screenshots, but this was true of Trump's website the day of the election. Trump's website had a page. They're like news press release page, and it had the headline for the press release in the URL. You could type in anything you wanted, it would just appear there. And everybody was making ones with all sorts of ridiculous headlines. It was going all over the place, and then they finally turned it off. But I didn't try script tags. I should have, but anyway. And I think he's just using some platform like WordPress or something, and the way it's written is your headlines just have the headline up there in the URL, which appears on the page. It's exactly this document object model based XSS thing That just seems to be a fairly common thing people do. I don't know why. There's these RESTful URLs where they put parameters and they look like they're in the path, and there's this stuff where they put content in the URL, which then goes on the page. It's just, I don't know why people do that, but it is fashionable these days, so I'm seeing a lot of it. Yeah?
On Hillary's location one, like one of the location pages or something like that, you could put in a URL encoded request and have it appear on the page. Also,
Aries.
really like that.
That's Aries location?
No, it was something like, it was asking about the location of like a Hillary thing near you or something like that, and if you just added the URL.
The politician stuff, yeah.
Yeah.
Yeah, the political stuff tends to be the worst because it's thrown up in a hurry by volunteers and usually full of all sorts of mistakes. Anyway, so now I can inject Trojan functionality into it. I can put in I can inject a fake login form. You know, here I was able to inject a link and a message that wasn't there. I could put in a whole form tag with a button where you put in your name and password and click the button and go somewhere, and it would all be just from up there in the URL. So the code, not a code the developer put there at all. I can put on a fake Google purchase form. This is one that really happened to Google in 2004. Google had a cross-site scripting vulnerability where you could put code in the URL, and so they put up an entire page here saying Google will now become a subscription service. You have to pay $10 now for a lifetime subscription to Google, put in your credit card number and buy. And all that code is in the URL. This is not on Google server at all. You can put a whole page in the URL, and it really appears your browser really thinks it's talking to Google, and you're really not talking to Google. It's bloody awesome. All right, so anyway, so the attacker, if you do a session hijacking, you have to keep taking cookies off the server and then carry on actions on behalf of the user. So they have to harvest the cookies, put them in something, break into sessions to steal their money. How much bother is that? It would be so much more fun to just make the cross-site scripting directly do what you want, where it actually executes the code to move your money into my account. I'm not even stealing your session cookie. I'll just move the money into my account every time you view that page. And so you can do that. You can put your whole payload in the URL where it does your whole attack. And you don't even have to like harvest the cookies or anything. This is another attack they call tab napping, where you are on one page and it goes to the other tab where you're still logged into Amazon and buys my book. All right, and the XSS worm did this. The guy did not have to harvest credentials and get in other people's accounts. It just added him to their friends list and spread as soon as they saw the page. Automatically it did the attack and went on. He didn't have to do anything. Spread like a virus. And then you can exploit trust relationships, and ultimately all these things are exploiting trust relationships. Your browser trusts every page that starts as facebook.com to handle Facebook confidential data, like the cookie. And I'm tricking it into thinking it's at Facebook when it's not really at Facebook in the way that matters. And that's the game here. Another thing that's fun is Internet Explorer's trusted site. Internet Explorer, if you put things in the trusted site zone, it can now run local objects through the browser. This is one of Microsoft's many highly disturbing design decisions that people got really mad about. See, AOL owned the internet. And there was a ton of people that got something in a newspaper, they put it on their machine, they would open it up, they'd be on AOL, and they thought AOL was the internet. They did not understand what a web page was or anything, they just thought AOL owned the whole thing. Microsoft saw that and was very envious. And so with Windows 98, they tried to repeat that. So that your browser would be like web TV. They made it so you could put an active page like yahoo.com as your desktop background, and you're just on the internet all the time, always in the browser, never leaving it, and Microsoft owns everything. They wanted to be like AOL. And therefore, they mixed local exploring and internet exploring. And if you can go to Internet Explorer and you can type in a local URL like C Windows System 32 CMD, and it will go there and open the local browser. And you can open Windows Explorer and type in http://yahoo.com and it will open Internet Explorer. They merged them completely, with the goal being that users don't know or need to know or care whether they're on their machine or on the internet. It'll all just be one seamless experience, all branded with Microsoft, because they saw AOL getting rich off of that. And so that led to this. If you trust a website, you then trust it to run local scripts. This is a WScript shell. This is going to run calc.exe. I can now launch local apps from a URL because it treats your own machine the same way it treats the internet. This is one of their highly controversial design decisions, but that's how Windows really works. ActiveX, I think ActiveX might finally be on the decline. ActiveX was Microsoft's way to run compiled code competing with Java, and very dangerous. And after ActiveX could do anything. It could format your drive, because they use ActiveX for Windows Update and for antivirus scanning for websites. I mean, it can do anything. Send email, format your drive, install software, practically anything. So in order to prevent that, the developer that writes an ActiveX control can put a flag in to say whether it's safe for scripting or not. Because I don't know what Microsoft's threat model here is, but they think that bad guys can't write ActiveX controls, only real companies can, and they will mark which ones are safe for scripting or not, but that's kind of pointless. So now the attacker can just put that flag in his script, and then it'll run on a web page. It's kind of backwards, like the San Francisco parking meters that would ask the card whether you had enough money, not the meter. Card just had to be programmed to say yes, and you always have enough money. Anyway, so you can attack users, you can catch their browsing history, their keystrokes, you can port scan a local network from it, and all that jazz. So to deliver these things, if you want to deliver reflected SSS, you have to put it all in the URL and then get people to click on the URL. So typically you email it or IM it, or you put it on a website that lets you post XML like Facebook or something. The watering hole attack is the most popular one now. This is, I understand, the most common way people get infected. You just infect a page and you wait for them to visit. And there are pages that automatically scrape Google for the biggest searches and put it on the page to get to the top. There are people this started with China. China hacked Tibetan activists. They made special pages full of news about Tibetan activism, and they filled them with malware because they knew all the Tibetans would go there, and that's who they were trying to target. And it's become quite common, this watering hole. So now people go there, and that page infects them or steals their cookies and so on. The DOM-based and reflected, there are a lot of ways to do it. One way is to just put a malicious URL in an ad. Like I say, the simplest way, purchase an ad. And what's funny is if you put content in the ad about the people you're attacking, it will often, like you want to steal WordPress cookies, you can put content in your ad about WordPress and it will actually appear on WordPress pages because they're paying Google to put ads topical to them. So you'll often hit just the right people very easily because that's the miracle of Google's targeted advertising. You will hit exactly the people on topic for you. Now, what's even more fun, I remember I found a bunch of these at colleges back when I was still warning colleges before I found out you're not supposed to do that. They have this feature where you can recommend this page to someone else. They have a news page. And that opens an email thing, and you're filling in form, and it's sending an email from their server. And you can modify it to send email to other people with other content. And I said, dude, I could just totally send spam from your company. And of course, as usual, they can't understand me, and they just think I'm a criminal or something. But anyway, this is common. So you can, and if you can send emails, you can also send emails inside the company that appear to come from someone in the company. Like, I'm traveling, please turn off the firewall and reset the password like they did for HP Gary. I mean, once you can create emails that appear to come from inside the company, social engineering becomes much more effective. So those forms are pretty risky. So anyway, to deliver these stored attacks, the most common thing is you just have some field you fill in, which is repeated, like your profile or something, names of documents. You can often put tags in the names of files, not even the content of files, because the name will appear on the screen and it might have a script tag in it. And feedback and messages and so on, these things. Anything recorded in logs and repeated back, like error logs or anything else. And of course, if you can upload files, you can put tags in the file and then people download the file you've got on their machine. So there's a lot of these. That's all called in-band, where people are actually going to go on Facebook and you're getting other people who are on Facebook looking at stuff Facebook put on the page. And then there's out-of-band, where you send email to people from the server that now includes scripting. And as we've talked in these realistic examples, the cross-site scripting alone is usually not enough to do anything terrible. It's part of a series of vulnerabilities that lead to a disaster. So here's an example. Cross-site scripting lets you put a script in a user's displayed name, but an access control flaw lets me change other people's names. So now I put a script in everybody's name. Now everybody that used the page gets attacked. You see their name and it sends their cookie to me. All right. So that's the first half of cross-site scripting, and the first third of it or so. Let me save that, chapter 12.